Okay. So it is Berkeley time. I know there's only a few of us here, so we'll just get started on today's content. For today's coding lecture, we are getting into JavaScript. I'm just going to skip over the first few slides. We will revisit it. But for announcements, we have Homework 7 released today, as always, due next Thursday. And we have our mid-semester survey due by the end of day today. So if you haven't done that already, go ahead and fill that out. That is just free extra credit, so you should just do it. And then we will be sending out grade reports. So it'll be detailed description of the breakdown between homeworks, labs, and the midterm itself. And that will come directly via email from your TA. And yes, we are wrapping up the semester. We only have 4 more lectures after today, and you do need 4 to pass. So since you guys are all here, you only need at most 3 more. I'm assuming you guys have gone to more than just today's though. And of course, keep your eyes peeled for our final project. That's kind of like the most exciting part of the course, where we get to design your own website from scratch. Yeah, and we will release details for that soon. So just an overview, we already have covered everything we will learn for HTML and CSS. And now strictly moving forward, we'll only be covering JavaScript and kind of how it interacts with those first 2. And just, sorry, let me go back. Okay, and just to reiterate, HTML and CSS have only described kind of the page structure and kind of like style information. But JavaScript will kind of bring this new element of interactivity. And yeah, so in a way, it's very like different from the other 2, but we'll still be using HTML and CSS. And so some of the core questions we'll be answering in today's lecture are, what is JavaScript? How does it compare? How does it differ from HTML and CSS? What can we do with it? So how can we manipulate it to change existing predefined code written in HTML and CSS? What does it look like? So what are some of the nuances of the language, some syntax differences? And then we'll go over some hands-on basics so we can get a little more familiar with the fundamentals of the language. So again, just to answer that first one, what is JavaScript? So technically, HTML and CSS aren't programming languages, even though we do use a code editor to change it. They're not technically programming languages, whereas JavaScript is a robust programming language. Sorry. I think over the years it has been expanded to have a lot more uses, but for the sake of this course, we're only going to look at how it manipulates HTML and CSS. And yeah, again, HTML and CSS tells the browser what we wanted things to look like. JavaScript is going to tell the browser what we want those things that we've specified and predefined, what we want those things to do, how we want them to change based on user behavior. And so what can we do with it? Right. So our goal, again, is to write code that adds interactivity. And again, I kind of already said this, but it's to change existing HTML and CSS in response to user behavior. So that 2-part kind of way of thinking is going to be really instrumental in kind of understanding what you want your code to do. So some examples that we might see in the context of web design would be pop-up dialogues, or if you want like those image carousels, you press an arrow and then images kind of slide across. Pretty much anything that is a little more advanced than what can be implemented using HTML and CSS, just think JavaScript. Moving on, so just to see what its role in the web page is. Yeah, when you load a web page, what do we see? We see everything that we've defined. HTML displays everything that we've defined in the HTML file. CSS will show up whatever we have defined for the styling. JavaScript is not inherently just going to pop up. Instead, it will rely on some user behavior, user interactivity for it to kind of trigger certain events or certain actions. And for now, we're not going to see how it manipulates HTML and CSS just yet. We're just going to see some like really basic things kind of in isolation. And so when we do eventually get to linking our JavaScript such that it can grab certain elements, we're going to use this line, similar to how we linked our CSS file, similar to how we also referenced images. We're going to use this file path here. So you can just like copy this line, but double check that whatever's within this string here matches where the actual JavaScript file lives. So if you don't have this exact directory structure, where you have the assets folder and within that a JS folder and within that your file, this won't work. So of course, don't just take this exactly word for word. Make sure it matches with your actual project structure. Okay, and I think this is probably the most important slide of this lecture, because this describes kind of the mental model that you want to have whenever you write any piece of JavaScript code. So whenever you think of adding a feature, whether it's a menu or a tab that kind of switches between views, you want to think of this kind of three-part structure. So when the user clicks on, it doesn't have to be a click, by the way. It can be like hover or like scroll. When the user does something, right, on this button, link, or image, so some HTML elements, when a user interacts with an HTML element, then what? We want to add, change, remove something about the HTML or CSS. So this three-part structure will identify, one, the target that we want the user to interact with, or that we expect the user to interact with. And then we want to think, well, how do we want the web page to respond? Well, we're going to manipulate something within the HTML and CSS. And so this is just kind of a basic coding principle. You always want to think about what your end goal is, and then you figure out your way there, right? So similar to how we had you guys create your low, mid, and high fidelity mockups before even starting on the coding portion, it's a lot easier to define what you want before you make it happen, right? Because if you just start coding right away, you're going to probably stumble, make a lot of errors, and it'll just be very time consuming. So this is kind of like the star slide of today's lecture. And so some examples, I'll just kind of start us off with the first one of how this might look for when we do connect HTML and CSS to JavaScript. Let's think about this first example. So when the user clicks on this image, so some HTML elements, then we want to increase its size. So connecting, again, this kind of like color coding here, the green and the red portions, if we go back. Sorry, this is a little slow. But yes, so again, the green and red is kind of what we want to happen to the HTML and CSS. So we want to increase its size. What might that look like? So assuming we know how JavaScript actually handles this, and assuming we know that JavaScript can do these things, we want to translate increase its size to maybe changing the CSS width and height. So for now, I'm just going to black box this. Don't worry about how to actually implement it. Assume JavaScript can just write code and manipulate code as you can to the HTML and CSS file, but kind of on demand and in response to behavior. So that's one thing JavaScript can do. Let's move on to the next example. Okay, ooh, here we go. So when the user clicks on this button, then change colors to dark mode. So let's take a minute to think about what might that mean. I think we've seen in dark mode, your text and your background color, they invert, not necessarily exactly invert, but one goes dark, the other goes light. Where do we find color? Well, in our CSS file. So again, if you can identify the correct CSS selectors and the correct HTML elements, then changing colors to dark mode, essentially in code language, is changing the CSS color and our background color. Okay, moving forward. Moving forward. Okay. So when the user clicks on this tab, then you want to change the content. Hopefully you guys didn't already read it, but what is the content? Maybe it's like a bunch of text, and I guess in reference to the midterm you guys just completed, if you were to switch between different tabs on the menu, maybe you want to display only the vegetarian options or only like the meat dishes, right? So you have two different boxes of text. Maybe we want to hide the first div, show the second div, right? And then back and forth, right? So maybe they both exist on the page, but also jumping into the CSS, maybe we're setting the display to none for one of them and display to block for the other one. So we're kind of just putting one visible and then making the other one not visible. That's one way we can achieve this. Of course, there's multiple ways of implementing this behavior, but as we get a little more experience with JavaScript, we'll kind of simplify it to the easiest version of that, such that it achieves the same end results. And then this one, we haven't really seen how this might be done, so I'll just skip to it. But if we can click this up arrow and we want to increase the number, one thing that JavaScript can also do is read the text within a div, change it, and then also update the div. So that's a useful property if we want to change text based on behavior. And so these 4 examples, we don't expect you to have like come up with it on your own because you guys haven't seen what JavaScript can do, but they're just kind of, you know, a starting point to get thinking, okay, how can we translate this behavior into tangible code? So any questions on anything we've seen so far? I think one thing is also like a big roadblock is just you don't even know what you can do. I think that's okay. I think if you can imagine what you want to do, there's a lot of documentation online to kind of get you started and point you in the right direction to see like how that might be written up. So if no questions, we'll just keep going. So again, we're not going to see all those concepts in play just yet. We're not going to see how we can manipulate things. We're just going to jump into like the basic syntax and little logical blocks that JavaScript can handle. So this is kind of what we're going to go through. Yeah, and by the end of today, you know, you're just going to be able to read basic syntax and then do, again, basic arithmetic. So an introduction to variables. So one thing that JavaScript does is, or a very instrumental part of JavaScript are the variables. And there's 2 parts. So there's the declaration and the initialization. Declaration is just telling the program, hey, I'm going to create a variable. I'm going to call it this name, and that's it. We haven't assigned a value to it. We're just saying there exists some variable that will eventually hold some value, okay? Initialization is the actual assignment of a value to that name that we have previously kind of defined. And so an example that maybe seems a little more relatable is if you've seen in math classes, like let k be 5, for example, the declaration is let k, right? You're queuing in that we're going to be dealing with some variable, and the initialization is, and that variable has this value 5. So that's kind of the one-to-one for declaration and initialization here. And pretty much once you've created a variable and you've created this entity with a certain name, you can also reassign the value to it. And you can also redeclare it. That one is not super useful, but the reassignment is. So variables can take on different values throughout the program's execution. Okay, sorry. So here's an example of JavaScript code that does just that, right? So as we saw, let k equals 5. In this case, we want to create a variable named name, and we want to assign it Joe. So the 2 types of variables that we're going to deal with in this class are strings, which are just like lines of text, and numbers. So that could be either integers or numbers with like decimal values as well. In this case, we're assigning our variable name the value Joe. So anytime we reference name in this code, it's going to refer to the string Joe. And similarly, we do the same with age, and we're going to assign the value 20 to it. And so again, or actually not again, but whenever you do reference text and you do want it to be caught as a string, we can't just say Joe without the text. Otherwise, it would think of that as a variable. We have to include the quotes to say, hey, this is a new string. Like, this is its own value. And also semicolons. So this is like a simple line of code in JavaScript. All right, and then these next few slides you can actually just kind of zone out for. I'm gonna just explain it so that if you need to refer to it in the video later, it's there. But there's a concept called variable scoping. So we saw let as the key word that told our program that we're going to create a variable. There's 2 others. One of them is var. The distinction between the 2 has to do with like scoping, which means when we have this inner block over here, friend, this lives within this block, and then name kind of like lives like globally, but both can be accessed like everywhere. Yeah, I'm just gonna move on actually. Okay, let's just go through this. All right. I've also linked a website if you do want to read up on it about how they're used. The 3, which are var, let, and my cursor will work, and const. They all have their own like use cases, but I'm just going to skip forward. We pretty much only use let. The differences are let keeps things a little more compartmentalized, so you can reuse the same name and it won't cause errors or like unexpected behavior. And then also for const, short for constant, essentially once you assign it a value, you can't reassign that value. So both of these little code segments won't work. But that's just for the recording. You can just move forward and always use that from now on. Okay. And then small thing here, one thing that JavaScript supports is string concatenation, which just means if you want to put two like lines of text and you want to make them their own string, you can do that. And you can use, so let's say we create the variable name and we assign Nicholas to it. We can do this. We can create a new variable greeting that now references this previously defined variable. And what do we think this is going to output? Or not output, but what do we think greeting will be? Well, we just put them together. Literally just left to right, just add it all together. Okay. And this one, when we are coding and we do want things, we want to check the values of certain things. There is a tool on your browser, similar to how you've used like inspect element. If you've done that, there's another tab that has console that will now output certain JavaScript. If you were to write console.log, if you were to write console.log somewhere in your code, whatever is within these parentheses, whatever valuable, whether it's a variable or just, you know, a value like a number or a string, it will print it out in that console for you to just kind of like check to make sure things are happening as you expect. And so if we were to run this code, as we saw previously, we already declared and initialized this. If we were to call console.log on greeting, which is this string, in our console, when we were to, if we are to navigate there, we should expect it to print out a little howdy Nicholas. And then this one isn't as important. This is kind of similar to console.log, except alert, if you were to do the same thing, but with alert, it would just have a little pop-up that you'd have to like close out. Not super useful, but just kind of fun if you want to just mess around. Okay, so now let's run through this. All right, seeing what we've seen so far, can we predict the behavior of these three lines? Well, nothing has happened yet, right? And then this one, okay? So string concatenation, we're putting it all together. So person, let's see, is I, emotion is love. Okay, cool. What do we expect this to be? Just think to yourself for a second. Boom. Okay, that might not have been what you guys thought, but one thing is, it literally, whenever you concatenate strings, it's just a little quirk about this, is it will not automatically fill spaces. It doesn't know that you want spaces. You have to be explicit about it. So if we wanted this to be spaced out like a real sentence, we should have added a space after the I and a space after the love. Or another way is to have added quotes with a space in between the words. Both, you know, have the same effect. Okay, now we're to alert this. As we saw, it should give us a little pop-up that now prints that string. So again, not particularly useful. We're just kind of getting familiar with the syntax. Okay. Oh, all right. Another thing that we saw is we can do some basic arithmetic. We have these operators here, plus and minus. They do exactly as you'd expect. The asterisk is used for multiplication. The forward slash is for division. And then percent, don't worry about the percent just yet. But yeah, some examples here. We have let age equals, and then we don't want to explicitly define it. You might be thinking, why don't we just set it to 25? Yes, in this very simple example, you would have just done 25, but this is just to show that we can do arithmetic. And yeah, again, we can double the age. We can reference this variable that was what? Most recently 17.5. And now double age is 35. So when we read this code, the lines will execute top to bottom, and variables will hold their most recently updated value. Okay, any questions before we move on? Okay, we'll keep going. There's not much left. The last part is kind of the meat of today's lecture, and it's a thing called functions. So one thing that we'll see a lot in code is if you find yourself repeating the same like logic over and over, let's say you just need to keep multiplying some numbers together over and over and over, and you don't want to just keep writing that same line over and over. One thing we can do to kind of encapsulate and reuse that logic, this is both for like less tedious code writing and also for easier to read code. We can define functions. Functions essentially define a certain like flow of logic that will take in an input and will return an output, and it'll do that same thing every time you reference it. So this is a nice way of keeping your code kind of compartmentalized. And yeah, for these next few examples, they'll just be like math related. So just as a syntax, just so you can read this from top to the bottom, function is just a keyword to cue us in that we are about to write a function. The next one that follows is the name of the function. We will always have the parentheses following it. What lies within the parentheses, you might not have anything, or you might have one thing, you might have three things. This is what we're going to call our parameters. These are our inputs. For now, we're just going to define it as this vague thing, which for now is just x. So x, whenever this function takes in, will, let's see, we're going to return x times x. Well, what does return mean? Return is essentially whatever referenced you is expecting you to give a value back. That's what the return key is doing. In this case, we are just multiplying it by itself, which is squaring the value. So whatever we put in, we expect to receive that value squared. So if we were to do the same thing, same logic here with the same setup, let's say we want a function that doubles our inputted number, right? We've named it accordingly, double. You always want your names to reflect kind of the behavior of your function. And it takes in, well, just one thing, in this case, n. What should go in that? Well, we just need to return n, but like doubled, right? So we can do n plus n, we can do 2 times n, both are valid. And then we make sure to close off our curly brace to say that is the end of our function. If you have multiple lines within your function, the curly brace will just be lower and will just cut off whenever you want the function to end. Okay. In this case, same thing, right? Except +1. Notice our name reflects that behavior. And just to make sure we don't run into any like issues of maybe 1 getting added to n before getting multiplied to 2, we can also use parentheses to separate, just as in math. There's no limit to how many parentheses you can use. So that's probably a clearer way to separate. And so how do we use these functions? We've defined it, but they just kind of exist on their own. They won't do anything unless we call them. So what does calling them look like? We saw earlier where we just gave a certain predefined value like 5 or 20 to these variables. Well, because we know that these functions expect a value and will give us back a value, we can also use them in the initialization of variables. So if we want y to be the square of some value, well, we can call our function that we've defined earlier here and pass in. We're going to call, anytime we give it inputs, we're going to call it passing in. We're going to pass in this value 5, which then the function handles. It does its little thing under the hood, and then it spits out, well, 25, right? So in this case, y will be 25, and z, now that we're referencing this variable, will be the square of that, which, I don't know, math people, what is that? 600? It's something, yeah. So that is how you can use your functions. And just as like I included this for a syntax thing, not all of your functions will have one parameter. Sometimes they'll have no parameters and they'll just do their own thing. But if we have multiple parameters, you would just separate them with like commas. The spaces are optional, but it's just for readability. So let's say we want to calculate the equation of a line, right? So if you guys remember, oh shoot, this should be ax plus b. I guess it's the same thing. But if you guys remember the formula for a line, maybe we're going to pass in all the coefficients a and b, and then our x, and we want to find out what y is. So that might be one way to do that. I'm just going to skip through since we already seen this. And so then we would call it with the same commas to separate between our different inputs. Whenever a function has a specified number of inputs, your call to the function has to match that number of inputs. So if I'm expecting 3 and you pass in 2, it's going to just bug out, right? So has to match, otherwise it won't function properly. . Okay, and then, oh, kind of already seen this. predefined functions, and yeah, double 2, that's 4. This is kind of repetitive, so I'm just gonna keep going. Okay. One other thing that's cool is we can reference functions pretty much anywhere in our code. So we can even reference them within other functions. So, calling back to this double function, let's say we want that thing from earlier, the double our inputted number plus 1. Well, we can use our previously defined double function and call it within this new function. So the path of this would be, if I were to call, okay, double 2, sure. If I were to assign second number to new double plus 1, this is kind of the flow of your code. This is how you want to think of it. Well, okay, we're calling this function. Cool. So we're jumping here and we're expecting x. And the x that we pass in is this variable 4. Okay, cool. So we're going to take this number 4 and we're going to jump to this line now. We're going to execute our code. But before we can return anything, we have to know what double is going to return. So then we jump to double, which then takes an n, which was 4. I'm kind of losing track here. And then we return 2 times 4. So 8. Okay, cool. So this is 8. So now this line knows that this is returning 8. Now we can move on. So now 8 plus 1 is 9. So then we return 9. And then, yeah, that's it. I talked really fast. I'm sorry about that. Anyone want me to go through anything on this slide again? Okay, we can always revisit it. We have the time. But that is one way we can see functions referenced within other functions. And again, so sometimes they don't return values. We've seen return in everything, but you can also just call functions without assigning a variable or without assigning a value to a variable. You can just call it, and that's a valid line of code. So if we want to just call show greeting and input this string, then it would just run on its own and then do whatever the function specified. So in this case, it would concatenate howdy plus the input plus exclamation mark, and then alert, it would give us this, well, we don't have it here, but it would give us the pop-up that we saw earlier. And then a small thing, I'm sure we've seen the comments, we've used it in CSS and HTML before, but the syntax for this one is just 2 forward slashes. Everything after that in that given line will just not be completely disregarded by the code. And if you want to comment out multiple lines without using the double slashes every time, well, then you can just enclose them with forward slash, asterisk, and then asterisk, forward slash. Everything within this will be ignored. Okay, let's try to figure out what this does. So we have this function, right? We've defined it with a certain name. It's not revealing what it does. We take in a course and a number. We do something here, and then we return res. Res is just kind of short for results. Yeah, and then we assign whatever it returns to something. So let's take 10 seconds, and then anyone know what this might output? Feel free to raise your hand if you have an idea. This is not a trick question, by the way. Let me move this up. Okay, never mind. All right, what do we think this is going to return? Or what do we think something is going to hold? Yes.
I have taken the 105.
Yep, I think that is right. Oh, yeah, that's right. That's right. And so just to double check our reasoning here, again, num, which is 10, we add 90 to it. And course, which is the string, you can also use single quotes. Those are also acceptable. Gets concatenated into the string. One thing is you might have been stuck here. JavaScript just figures if you're concatenating strings and then you put a number somewhere in between, it'll just say, hey, that's a string too. So it doesn't freak out. It just treats it as a string. And yeah, it would print out exactly what you said. Okay. Okay, I think that is the end of this lecture. So do we have any questions